Are you ready to recording? Quiet down. Ashwin. Ashwin. All right, so today's lesson is very much building on from what you learned from 7B and 7C. We still use balancing the equation, means you still need to know SAM-dub. This is the order that you're going to focus on getting rid of problems. So subtraction, addition first, get rid of those first before multiplication, division. That's second, and any brackets you do last. Okay, so let's look at our problem here. Today's lesson, 5x minus 1 is equal to 3x plus 5. This is different to 7b and 7c, not because it has any fractions, which it doesn't. It is not that it's similar to 7b because it has x's as well, but the difference here is that both left side and the right side, there is an x. That makes it harder, okay? So the one trick that I'm going to teach you today is to simplify the problem to bring it back to exercise 7b. How do you do it? Very easy. Same concept. Whatever you do to one side, you do to the other, right? So notice you've got a 5x on one side and you've got a 3x on the other side. Ideally, when we're solving problems, we don't want two x's. The more x's you have, the more problematic it becomes. Okay? The less x's you have, the less unknowns you have, the easier it is to solve. All right, so as you go into the higher year levels, there will be more x's and more y's and more z's. Makes it harder to solve. Your job at the junior level is to try to simplify it so there's not two x's. So how do you get rid of it? Well, same idea. You can still add or subtract both sides to get rid of one of these terms. So notice here, you've got a 5x, that's a positive 5x. This is a positive 3x. Now, out of these two, you have an option, or two options. You can either say, option 1, subtract 5x on both sides, or option 2, subtract 3x on both sides. Both of which will work, but one of which, a lot of students make mistakes, and a lot of students find harder to do. One of them will give you a negative answer. Which one is it? Is it approach 1 or is it approach 2? Hi. Number 1 will give you a negative approach. So notice here, what's 5x take away 5x? 0. So this will cancel out. If I did 5x take away 5x on the left, that cancels out. That's nice. But then over here, 3x minus 5x gives you a negative 2x. Now, depending on how you did in 7b, some students struggle with a negative 2 in front of the x because they think that's minus 2. It's not minus 2, that's times by negative 2. So a lot of students make a mistake here. So my encouragement to avoid that problem is to take approach 2. Approach 2, if you look at it now, if I do it again, so let's take away approach 1. Notice that when I subtract it now, 3x take away 3x is still 0, still counts as off. But the nice thing is 5 take away 3 will give me a nice positive 2x. And a lot of students are more likely to solve a problem when you have a positive 2x. So how do you ensure that you're going to do step 2 or approach 2 every time? Very easy. Choose the smaller one of the two. Get rid of the smaller one. And the logic makes sense because if you have a lot of money, right? Let's say you've got $100. If you take away a lot of money, you end up more closer to the negative. But if you take off only a little chunk, then you always have positive money left over. True? So here, out of 5x and 3x, it's kind of like your amount of money. Do you take out a lot more money or do you take less money out? If you take less money out, you will always have a positive. That's the idea. Yeah? So my tip here is when you're solving these problems, get rid of the x's first. And what you do is you get rid of the smaller x. So here's an example. 2 x's. I've got a 4x. I've got 9x. Which one should I take away first? 4x because it's smaller. So this one is a positive 4x. I then say take away 4x because that's the opposite of positive 4. But what if you do one side? You must. So I minus 4x on this side. Now the beauty in doing this is this will leave you with a positive answer. 4x take away 4x cancels out. I still have 19 is equal to 9x take away 4x gives you 5x. Very good, Colleen. So 5x, and you still have that plus 4, and you're back to 7b. So exercise 7b, this is the two-step equations that you've been practicing. Okay? This is where you use SAMDOB. I'm going to do the same thing for the first example. Let's do it again. So I'm going to rub this out, and let's do the same thing. Out of 5x and 3x, 3x is smaller. This is a positive 3x. So the opposite of positive 3x is? Negative. So I'm minus 3x on the right-hand side. But whatever you do to one side, you must do it to the other. So minus 3x on the left. Then you can see here, 3x take away 3x is 0. You end up with 5 on the right-hand side. And then 5x take away 3x gives you 2x minus 1. Very good. And you're back to, again, the same examples in exercise 7b. This is called a two-step equation. So when I look through your homework, what I'm looking for is, do you understand how to do a two-step equation? Yeah? For those who haven't yet practiced 7b, here we go. SAMDOB. Get rid of any subtraction addition first. Do you see any subtraction or addition? Where? The minus 1. Very good. This minus 1 is the subtraction. That 2, what is this 2 and the x doing? Timesing. So this is a times. This is subtraction. So out of the 2, which one do I get rid of first? It's not the opposite of times. It's the opposite of subtraction because SAMDOB. So getting rid of minus 1, the opposite of minus 1 is? Plus 1. Whatever you do to one side, do to the other. So here we go. Negative 1 plus 1 cancels out. I get 2x is equal to 5 plus 1, which is 6. And remember, that actually means they're times. That's 2 times x. So the opposite of times, divide. But since I'm doing x times 2, then the opposite of that is divide by 2. Very good. So again, let's check your understanding. What's 2 divided by 2? 1. Good, not 0. So a lot of students say 0. It's not 0. 2 divided by 2 is 1. That's why 1 times x gives you 1x. We're just too lazy to write the 1. 6 divided by 2 is 3. Okay, so this is 1. Don't write 0. Okay, it's the understanding it's actually 1. All right, let's see if the other one's also 3. Let's check. SAMDOB, do I have any subtraction or addition over here? Can I please have Leon?
Yeah.
Yes, which one?
19.
Got a 19, that's true. That's a 19 there. But we're trying to solve for x here. So on this side of the equation, do you see any plus or a minus?
Yeah, 4.
4. So there's that plus 4 there. So we're going to get rid of the plus 4s first. Here we go. Opposite of plus 4 is, Tom? What's opposite of plus 4? Minus 4. So minus 4 on the right. Whatever you do to one side, do to the other. 19 minus 4 is 15. 4 take away 4 cancels out to be 0. 5x, which means 5 times x. That's a times. Hauschwan, the opposite of times 5? Divide by 5. Whatever you do to one side, you do to the other. 5 divided by 5 is 1. That's why we say 1x is equal to 15 divided by 5. And Sully was correct before. X does equal to 3. Well done. So far, so good? Okay, so really, if you think about it, it's just the first step. In 7D, 7D brings you back to 7B. So if you've been practicing 7B and 7C, 7D is just one extra step. Okay? Let's do one more example, or 2 more examples, because I'm now putting in negatives. Let's see if you can pick up. Same idea. You got 2 x's. The x's is a problem. So we're going to get rid of them. But which one do I get rid of now? Is it the negative 8x or is it the negative 14x? Which one's smaller?
No, negative 14.
Negative 14. Think about the number line. Which one is the smaller value? The more negative you go, it's actually negative 14. And you can test it and you'll see what I mean. If you did plus 8x, you end up in a negative zone there. So in this case, it was easier to actually do plus 14x because that's the smaller number. I know the number is 14, but the negative tells you it's more smaller. So plus 14x on one side, plus 14x on the other, and you'll see. Very good. Oh no. 14 take away 8 is?
No, sorry.
6. 6x. So 6x, and notice it's a positive. You want to work in positives, ideally. Sometimes you can't, but with this technique, you usually will. Minus 1 is equal to 5. So you brought from 7D to 7B. Yeah, this is 7B practice. So as you're doing 7D, you're doing just one small extra step. And all you do is get rid of the x's. But which one do you get rid of? Get the smaller one. Okay, so think about the number line. Get rid of the smaller one. And you'll generally have a better equation to work with. All right, from here, Sam Dobb again. Do I have any subtraction or addition? Can I please have man?
5.
Yes, I've got a 5 here, but remember we're trying to solve for x. Yes, that -1. That -1. I don't want it to have that -1, so get rid of that. Opposite of -1, man? +1. Whatever you do to one side, do to the other. Let's go. -1 plus 1 cancels out to be 0, so you get 6x is equal to 5 plus 1, which is 6. Liam, what do you do next? Divide by 6, because that's times 6. When you write a 6 next to an x, it means times. So the opposite of times is divide. Whatever you do to one side, you do to the other. 6 divided by 6 is 1. So x is equal to 1. Very good. So that's with me putting 2 negatives there, and you were still able to do it. This time, I spiffed up the answer just a bit. Okay, now the textbook may do this in the enrichment area, and it may not. But let's see, same techniques, nothing's different. Just don't get scared about this, okay? So here we go, let's try it again. Next example, x minus 2, and you've got a negative 9x. Now you've got 2 x's again. Now which one do you get rid of?
9.
The 9, very good, because that's negative 9 and that's a positive 1. So, opposite of minus 9x. Josh, what's the opposite of minus 9x? Plus 9x. Add 9x on the right, add 9x on the left. Negative 9x plus 9x cancels out. And x plus 9 gives you 10x minus 2 equals to negative 12. Okay, so far so good. And then, oh, it actually works out nice. I was trying to make it not to work out nice, but it actually works out nice. That's too bad. I was actually trying to get you to have a fraction answer. It's okay to have a fraction. Doesn't always have to be a whole number. Okay, so if you happen to get a fraction, it's okay. Actually, I should have changed that to a +2. Then it would have worked out. But that's okay. Here we go. To get rid of Sam Dobb, we're going to say get rid of any subtraction or addition, and that's -2. Opposite of -2 is +2. Negative 2 plus 2 cancels out, so you end up with 10x equals 2. Negative 12 plus 2 is negative 10. Very good. And then dividing both sides by 10, because this is a times 10. X is then equal to negative 1. So my example was not so good there. I actually wanted the answer to be a fraction, but it turns out I created one that worked out nicely. Okay, so if I wanted to change it, I would have just put a +2 here. That would have been minus 14, and then minus 14 on 10. It's okay to have a fraction. Okay, it's okay to have a fraction. All right, team, can you flip over the page now? Flip over the page. What we just did so far was 7D. These are 2 examples that you can practice. I'll write up the solutions later. But for those who feel really confident with what I just taught, then you can apply it to a geometrical problem, combining what you learnt in term 1, geometry. You can put this together. That's only if you're very confident in term 1 content and you're confident with today's lesson. If you're not, don't do this. Yeah, this is enrichment for 7D. So it ties back to your understanding about vertically opposites, parallel lines, opposite angles, co-interior, alternate angles. If anything I just said you don't remember, don't do. Just work on the 7D skills I just taught. All right? All right, team, that's 15 minutes of my time.